afternoon, everyone. It's my great pleasure to welcome you to the 5th International Conference on Information and Communication Technologies for Intelligent Systems Review on behalf of ICTIS 2021 and Global Knowledge Research Foundation. We are thankful to everyone who present on this digital platform to make this conference more current. During this unpredictable circumstances of COVID-19, we wish everyone and their families a protected time and we will have a participation. I hope you will enjoy 2 days of the knowledgeful and interactive sessions. Now, I would like to introduce our two session chair of the session. First one is Dr. Nilesh Popat Savle and another Dr. Kita Nawale. Hello, Nilesh sir. He is the Associate Professor, Head of Department at the JSPM Imperial College of Engineering and Research Student. He has 10 years of teaching and his areas of interest include data mining, networking, and art. Another session chair we have Gita Nawale. She is a professor and head of department in Department of Computer Engineering at Singhal Institute of Technology and Science, Pune, and she is expertise in data encryption, PHP, security, and crypto. Welcome to the session.
Thank you, ma'am. Thank you.
Now we will start with our papers. Our presentation. That is our 8 minutes for presentation. At 7th minute, I will raise a hand to the mic, and I request all the presenters to be while the presentation is going on, kindly be.
Yeah, can you see my screen now?
Yes, you can share your screen.
Okay. Is my screen visible?
Yes, yes.
Just a second. Yeah, so good afternoon, one and all. My name is Sanjay. I'm a postgraduate student in Christ University. So the research topic that I'm going to be presenting today is an approach for credit card churn prediction using gradient descent under the guidance of Mr. K.T. Thomas, sir. So here first I would like to start to discuss about my domain. So I've taken a banking domain, to be precise, a credit card sector. So here my main intention for this project is to see the churners and non-churners. So for a banking company, it is very important for them to retain their customers, then to get new customers, so that they can come up with various loans or offers so that they can retain their customers. So these are some of the papers that I found regarding the domain. So here we can see that various models like logistic regression, multi-layer perceptron, SVM, K-means, decision trees are performed. And here you can see that.
Your presentation.
Sorry, ma'am.
Can you explain your presentation, please?
Yes, ma'am. Can't you hear me?
Yes,
Hello.
Yes.
Can I proceed?
Okay, but can you full screen?
Yeah, 1 second. Oh, yeah. Now it's.
Yes.
Yeah. Now is it okay?
Yes.
Yeah. So here you can see that deep neural network achieved accuracy of 87%. Rough K-means combined with SVM got an accuracy of 93, and the decision tree achieved an accuracy of 95%. But the gaps that I've identified in the literature is the activation functions play a major role in the deep neural networks. So we need to use efficient activation functions in the hidden layers to maximize the accuracy. And the other thing that I've identified here is in the literature review, I haven't come across any feature engineering or balancing of the data set or feature scaling. They've just taken the data set and directly applied the algorithms, and then they have got the accuracy. The accuracy might be poor, but the model may be biased. So here, my objective is to build a neural network model using gradient descent for customer churn prediction with feature engineering to get better classification accuracy. So for the data collection part, the data set is used for classification of churners and non-churners in the banking customer churn. Here, we are classifying the churners and non-churners. The data set contains around 10,000 rows and about 24 attributes. The data set is downloaded from Kaggle, and it is in the form of a CSV file. So here I'll be going through the data preparation steps that I've done. So first, I have removed the noise meaning the categorical values. So if you put categorical values in the model, it won't accept. So you will have to convert them into numerical values. So here I have replaced like few attributes like gender, geography with 0 and 1. And here I have done this using the pandas library. And next one, I have scaled all the numerical values from the scale of 0 to 1 so that the algorithm can perform better and it takes less time, because as all the values are scaled between 0 to 1. The next part, I have done some feature engineering, like taking two columns like tenure and age and deriving a column tenure by age. This is just an example. I've done a bit more feature engineering, and then we have balanced the data set using SMORT algorithm, that is synthetic minority oversampling technique. And then feature selection, I have done a feature selection for the attributes. I've used mutual classy info function from the scikit library. And this is the architecture of my model. So first the data is loaded, then the pre-processing of the data is done, then the features are scaled, then the data is balanced, then the data is split into train and test, then the neural network is designed, the parameters are set, the model is trained, tested, and the best accuracy is obtained. So here for the algorithm part, I am using artificial network as now, as at the present age, the amount of data is pretty big. So machine learning algorithms suffer whereas artificial neural network algorithms, can model complex patterns better than the machine learning algorithms. So this is my model architecture. I'll directly skip this and go to the table. So here in the first layer, I've used 40 neurons and I've used the ReLU activation functions in the first layer. And in the hidden layer, I've used 15 neurons. And for the output layer, I've used sigmoid activation function. The dropout is kept at 0.3. The kernel initializer that I've used is uniform kernel initializer. And I've used binary cross entropy. And the learning rate, I've kept it at 0.001. So the model scoring. So after the data is trained, the performance is valued on metrics like accuracy, ROC curve, etc. So these are the results and interpretations of my research. So after training the model on the seen data, now we have to test it on the unseen data. So here, as you can see, with feature engineering, the training accuracy that I've obtained is 78.14%, and the test accuracy I've obtained is 84.09. But without feature engineering, the training accuracy is less by 2%. You can see it is 77, and the same goes for the test accuracy. So the conclusion that I can infer is that the model implemented with feature engineering has improved the training accuracy by 2% and the testing accuracy by 1%. The model can be trained with huge amounts of data and other model architectures with using different layers, activation functions, and assembling techniques for achieving better performance. So these are the references that I have used. Thank you.
Hello.
Yeah. Hello, ma'am.
Yeah. Sanjay,
Yes, ma'am.
you have tested your results only on one data set, or have you tried on another data sets also?
Only one data set, ma'am. I just took a data set, I balanced it, I did all the data preparation, feature engineering on that data set, and this is just a model, ma'am, just to show that you can use neural networks and other activation functions, and you can change the learning rate, etc., to increase the performance of the model.
Then how or do you have any plans to validate your results against any other data sets?
Yes, ma'am. In the future, I'm planning to confirm, go further into this. This is just a starting step that I've done over here, ma'am. The initial part.
Okay. Okay.
What is your highest AUC score? whenever you validate it, what is your highest AUC score?
AUC score, sir?
Yeah.
Yeah, just 1 second, sir. I have got 76%, sir, AUC score.
So whether it is increased or
It is increased by 3% without the.
have you checked that ADA boost and XG boost classifiers?
Yes, sir. I've actually, for the optimizers, I checked all the ad grad, Adam, and everything, but I got SGD gave me better performance than the other test.
As per my knowledge, ADA boost and XG
Yeah,
boost.
XG boost should give better accuracy, but I is just getting the similar accuracy, just 81.23 would have been 81.24. So like very less difference. So I've just gone with the stochastic gradient descent.
Yeah, means as per your this analysis, yeah, XG boost and this gives you the same accuracy.
Yes, almost the same. It's just point, like if I get 81.23, the XG boost I might get 81.24. So if I take the first point, it's almost similar for the data set that I am working on. So for other data sets, I'm not.
That's it from my side.
Oh.
Yes, thank you. Yes, our next presenter, Hang Lian. Are you there?
Yes.
Now you can start your presentation. You can share your screen, please.
Hi, everyone. Today, I'm going to introduce our research, a deep learning approach to extracted integrated meaningful keywords from social network posts with image, text, and hashtags. SNS not only enable users to communicate with their family, friends, but also help enterprises to contact their customers for business purpose. Using the SNS, user might create different types of content, such as profile, post, like, or check-in. SNS providers could analyze this user data to understand their users and to provide them with related information or advertisements. In addition to numeric and textual content, there are a large amount of user-generated non-textual content, such as photo, music, and video. The non-textual content may reveal users' personal interests. As a user shares photos about children's site often, it may possibly mean that the user is interested in tourism-related content. Therefore, it's important to analyze both textual and non-textual contents for understand users' interests. SNS providers usually apply only content analysis to passive text description, hashtags, and comment to extract the possible meaning of the textual content. However, what would happen if an Instagram post does not include any text description or hashtags, but only has a photo? In another situation, when the photos, text descriptions, and hashtags have discrepancy, it would be hard to acquire a consistent meaning of the post by traditional content analysis only. To be more specific, assuming that an Instagram post includes a meal photo, a text description as Happy Friday night, and hashtags with happy and relax. Ideally, in this case, the service provider should provide the user with the meal or restaurant-related contents. But according to the text description and hashtags, the users might receive massage or nightclub-related content. To deal with this problem, our research aims to extract meaningful keywords by jointly considering photo, text descriptions, and hashtags of a post to acquire the complete information embedded in the 3 types of content objects. A deep learning-based keywords extraction process that integrates ResNet 50, word-to-vector, and digestion algorithm is proposed. The proposed extraction process as the slide. First step, an Instagram post is divided into, it's divided into 3 parts, including image, text description, and hashtags. We apply a Chinese text segmentation tool, J8, to segment text description to a sequence of words. Second step, the ResNet is trained by the CRFIR10 dataset. There are 10 classes in the dataset. The validated accuracy of ResNet is 0.92. The training parameters of ResNet is adapted from previous research. The word-to-vector model is trained by the corpus of latest backup Chinese Wikipedia. Wikipedia is considered as an ideal knowledge base for data mining systems to find auxiliary data to improve performance. In this process, word-to-vector firstly builds a vocabulary from training text corpus and then learn the vector representations of each word. In addition, word-to-vector calculates the cosine distance among specified word vectors. Third step, we apply this model to the post. ResNet 50 is used to gain the predict classification labels of the image. And word-to-vector is applied to identify the concurrency rates among labels of image and segmented words of text description. It's also applied to identify the concurrency rate among segmented words of text description and hashtags. Fourth step, we build a multi-stage graph weighted with the pair of concurrency rates of image labels, segmented words, and hashtags, and then consider it as a longest path problem. Finally, the consistent keywords among image labels, segmented words, and hashtags are extracted after resolving the longest path problem by adapting digestion algorithm. An Instagram post is used as an illustrative example for our proposed process. The original text descriptions of the post are "Can I eat it?" and "Purple sweet potato smells good." The hashtags of the post are "fresh pet food" and "meatball." After data preprocessing, the post is divided into image, 3 segmented words, and 2 hashtags. Next, the image is entered to ResNet to gain the predict classification labels. The recognition result is dog. Next step, the image label, segmented words, and hashtag are entered to word-to-vector to get the concurrency rate. The concurrency rate of the image label and segmented words as the slide. For instance, the concurrency rate of dog and it is 0.37. And the concurrency rate of segmented words and hashtags as the slide. For instance, the concurrency rate of it and fresh pet food is 0.45. Finally, a multi-stage graph weighted with the pairs of concurrency rate of image labels, segmented words, and hashtags is built. Resolving it by digestion algorithm, the longest path is dog to it and then to meatball, with maximal distance 0.91. The result indicates that the consistent 3 keywords are acquired as dog, it, and meatball. It's noted that the keyword dog extracted from the image has not been mentioned in the text description and hashtags. In this research, a meaningful keywords extraction process of SNS posts is proposed by jointly considering image, text description, and hashtags. The process integrates ResNet 50, word-to-vector, and digestion algorithm. This process, involving 3 types of content objects, can be helpful for advertisers to deliver matched ads to SNS users for creating more business value. Thank you for your attention.
Hello.
Yes.
You got the accuracy something about 0.92, no? That figure is something 0.92, right?
Yeah.
How did you calculate actually this accuracy?
Sorry.
How did you arrive at this figure? Hello.
Yes. Wait.
Yeah, you got the question?
Yes. You mean this one? 0.91.
Yes, yes.
Yeah. It's a concurrency rate with dog and it and dog and meatball. We calculate.
So actually in this path from dog to eat that you have calculated as 0.37. So how this figure is calculated?
Sorry, I can get your point.
There is a path from dog to eat, right? First path.
Okay, that's image label and segmented words, their concurrency rate. The concurrency rate of dog and it is 0.37. And then we add it to the it and meatball 0.54.
Yeah. Okay.
Yes, thank you.
Yeah, thank you.
Just a minute. Huh? Can you tell me, have you combined the features of engineering stage with somewhat like supervised learning stage?
Sorry?
Have you combined the features of engineering stage, that is your data preprocessing and feature enrichment, with your supervised learning stage?
You mean data preprocessing?
There are two stages. Whenever you are going for such an approach, we are having two stages, right? First one is feature engineering stage, and then we go for supervised learning stage where we have the model training and all that things. Have you done such a thing?
We just use, sorry, wait a minute.
Okay.
We just use the ResNet to recognize the image and we get it a label, such as dog.
Okay, for getting an image, have you combined some features of this supervised learning stage? For getting a train, you must have trained the model now for getting such things.
No. It's our preliminary research. We just to verify our concept is correct or not.
Right.
Thank you.
Yes. Next we have Sharat Kumar. Hello. Are you there? Hello, Sharat Kumar.
Yes, I'm here.
Now you can start your presentation.
Okay, thank you.
Share your screen.
Yes, I'm doing.
Good afternoon, everyone. I am Revati Raman Bhaire, an undergraduate computer engineering student currently studying at IUA Kulchak campus, Tribhuvan University, Nepal. Today, I am going to present on GAN-based two-step pipeline for real-world image super resolution. The outline for this presentation is shown here. First, we'll start with introduction, then we'll move to methodology, datasets, results and outputs, limitations, and finally conclusion and references. Let's start with the introduction. So basically, image super resolution is the task of transforming low resolution images to high resolution image with better perceptual quality. Image super resolution has wide application in diverse fields such as surveillance, medical imaging, remote sensing, object detection, gaming and graphics, etc. Most of the super resolution approaches are based on high resolution image and their synthetic bicubic low resolution image pairs. And such methods fails to generalize for real world low resolution images. Hence, the need of advanced super resolution techniques that will incorporate varieties of degradation of real world LR image is realized. Project, the main objective is to upscale the low resolution image to a high resolution with fine details and better perceptual quality. Also, our objective is to solve the problem of real world image degradation in image super resolution. Now let's move to methodologies. We implemented a two-step pipeline for addressing real-world image super resolution. At first, we transform the real-world low-resolution image into the space of bicubic alike low-resolution image using a bicubic real to bicubic generator, in short R2B generator. The transform bicubic low-resolution image is upscaled by the factor of 4 using an ESR GAN plus network. Here, it is a deep convolutional neural network with residual blocks at the core. For training the network, we implemented relativistic average discriminator based on a relativistic average GAN. Unlike
There might be a connectivity problem.
Yes.
can you continue?
Yes, yes.
Okay. The loss function we used while training is shown here. It is a weighted sum of pixel loss, perceptual loss, and adversarial loss. The pixel we used, we set the value of alpha to 1, beta to 3, and gamma to 1. The pixel loss is the measure of L1 norm of the difference between the pixel values of generated image and the ground truth image. The perceptual loss measures the L1 norm of the difference of high-level features extracted from BCG19 network. The adversarial loss estimates how well the network will use loss based on average discriminator loss as adversarial loss. The dataset we use to train, validate, and evaluate the models are shown here. We mainly use real SR dataset, deep2get dataset, and DPD cell phone dataset for this project. These all are publicly available public benchmark dataset for image super resolution. The exact number of images used are shown in table. Now we will continue to result and output section. Before that, let's discuss some evaluation metrics we used throughout this project. First is PSNR. PSNR computes the signal to noise ratio in decibels. The higher the value of PSNR, the better the quality of the generated image. Similarly, second is SSIM or structural similarity index measure that is used to measure the perceptual similarity between two images. This metric extracts the three key features from an image. luminance, contrast, and structure. It is also a full reference metric. Final one is PI or perceptual index, which is our non-reference metric. It is introduced in 2018 Prim Challenge on perceptual image super resolution. It is highly correlated with the rating of human observer. Lower the value of PI indicates better perceptual quality. The table shows the quantitative comparison of our proposed method with other state-of-the-art methods. The highlighted values are the best one. We can see that our method outperforms the other methods in perceptual index metric. The, the qualitative comparison also demonstrates the superiority of our method to other current methods.
Hello, Sharad.
Yes, ma'am. Is there any problem?
Yeah, you were not audible. That's why I called.
Sorry, ma'am. I think there is some issue with microphone also. From where I was not audible.
No, you can continue now.
Okay, ma'am.
And you have last 1 minute for it.
Okay, ma'am. One limitation of our project is there. Some generated image suffers from uneven artifact as shown in the figure. In summary, we have presented a GAN-based two-step pipeline for real-world image super resolution. We can further extend this project to improve the perceptual quality of the output image. Also, we can build single robust network for image super resolution. Here are few references used in this project. Thank you, ma'am. Thank you, everyone.
Okay, Sharad, in the loss function, you have used alpha, beta, and gamma, right?
Yes, ma'am.
So what are their values?
Ma'am, we set the value of alpha to 1, beta to 3, and gamma to 1.
Why?
It is
Why
completely,
not other values?
it was based on experimentation, and also the fact that the perceptual loss with results more better quality output, so we use that value.
And you have used that real to bicubic generator, right? R2B.
Yes, ma'am.
Why not any other generator? Why only R2B?
Ma'am, main aim of project is to transform real world low resolution image to bicubic image. That is only name we give to that generator. Actually, it transform real world low resolution image that has many varieties of degradation to bicubic low resolution image, which have only one distribution. So upscaling the bicubic low resolution image to high resolution image can be more effective or can incorporate real world image super resolution.
Okay, one last question is, you are saying that your method is superior, right?
Yes, ma'am.
Uh, can you tell me the things or on which you have worked, and the other researchers they have not worked, because of which you are getting your results which are superior?
Uh, Actually, ma'am, there are few methods that try to perform well on real world low resolution image. Among them, some of have used some methods or architectures that were old and not effective, and we have improved the networks with a more robust architecture like the relativistic average discriminator and the loss function, and we also used uh, features extracted from BGG19 network as perceptual loss that also improved the perceptual quality of output that resulted in better quantitative and qualitative results of our method.
Okay, thank you. Thank you.
Thank you, ma'am.
Question from my side.
Okay. No questions, sir?
Question from my side. Ma'am has already asked whatever to ask.
Yes, our next presenter, Kadam Vaishali Undlikaram. Are you there, madam?
Hello.
Yes.
Good evening, ma'am.
Yes. Yes.
Ma'am, shall I start?
Yeah, you can speak.
Same, ma'am, my screen is visible to you?
Not yet.
Try to share your screen. Madam.
Yes, ma'am.
Yes, it is visible, ma'am. You can start.
Okay, okay. These are the contents. So myself, Vaishali Kadam, from Dr. Babasaheb Ambedkar, Marathwada University. The paper title is The Rule-Based Approach for Marathi Part of Speech Tagging, and the ID is 682. This system is guided by Dr. C. Namrata Mahender, and we are from Department of Computer Science, Dr. Babasaheb Ambedkar, Marathwada University, Maharashtra, Aurangabad. These are the contents for my paper. And first of all, the introduction. Now, this paper is basically focused on the part of speech tagging. Now we know that this POS tagging is important task under the NLP. This NLP stands for Natural Language Processing. This is one of the subfield of computer science and human communication languages. This is NLP is introduced in early 1958. Mainly, this NLP is important for new language or developing new language technologies, and mainly designed for the machines to understand, analyze, and manipulate different types of human languages, and to make the machines more understandable for the humans and for their interpretations. Now, NLP are generally used for organizing large or particular knowledge, and they are generally used for language translation. For example, they are useful for automatic summarization, name entity recognition, or speech recognitions. Morely, this POS, this is the process of assigning a grammatical name to each the word from the input sentence. Now, NLP algorithms are for machine learning. So instead of using large set of hand coding, large set of rules, grammar rules for any languages, NLP relies on machine learning and automatically learn the things through the example or analyzing a set of examples. So POS tagging is difficult for Marathi language, so we take we take it consideration, and so that we try to use or develop this system for the Marathi. Now the need of the POS tagging in NLP. This is used as a pre-processing tool for any NLP applications. Actually, this system is based on the rule base. There are two different types of systems. They are used when we study the literature and other things. So the rule-based systems are there, and some empirical-based systems are existing ones. Now the researchers face different problems in case of the many Indian languages. Like Indian languages are more morphological effects, and they are morphologically rich, so they generate different particular meaning for a single word also. So this is considered as the problem, and the main issue is the this is considered as the main issue for the language. It is in scientific word, it is considered as ambiguity for languages, and that's why it is a challenging problem for developing any NLP application. Now, exactly what is a POS tagging or POS tagging? when we do definitions, this is nothing but the process of automatically assignment of grammatic labels for each the word from the input sentence. Now here for this system we use Marathi text, so that's why this is the grammatical labeling for the Marathi text. And these labels are generally known as the lexicons or the lexicon or the notations, or generally the tag for the particular one or the word. So there are 8 different types of words they are existing for Marathi. They are known as Nam, Sarvanam, or Kriya, Pad, Kriya Vishan, like this. And the main classification of this word is, in short, POS tagging is nothing but the classification of words for their particular types, and they are known as the labels, or exactly the tagging for the particular word. So here we have some particular text. They are generally used for tagging. So here the next one is the POS tagging classification. When we do tagging for these particular words and the input text, they are classified under 2 different approaches. The main broad approaches are supervised POS tagging system and unsupervised POS tagging system. Supervised systems are they have their own predefined tag corpora or text through which we can test data and train data. And then unsupervised systems are those they are capable of automatically assign tag to the word. Now here this table shows POS tagging technique, different technique based on some another particular concept, which approach is used for designing the system. They are classified under 3 different particular types: rule based, stochastic based, and the hybrid based. As rule based systems are generally depends on the rule set of the language, and it requires the language expertise, whereas stochastic based are generally depends on some statistical formulations, and the techniques they are depends on stats. And the hybrid technology, these are the combination of rule based as well as the structural the statistical based together, so that we can design a more appropriate system that is more important or more gives more accuracy for tagging the particular words. So both means these 3 particular systems have their own advantages and disadvantages. Now here we consider this main system or main the approach is depends or related to the Marathi. So this is a POS tagging is a basic pre-processing tool for needed for the NLP application, as we consider and design it for Marathi language. So it is very difficult to design for the Marathi, because Marathi is a free word language and a free order language. So it generates many times it generates multiple meaning for the same word. So here I take one example: Mala supari lagte. In English, the sentence is I want betel nut, and betel nut is the unbecoming to my health. These are the 2 different meaning that are generated with the same sentence. So here the word lagte creates this type of confusion for understanding the language. So if a native from this language can understand the meaning of this according to the situation, exactly how this word is placed in the sentence, like the position of the word or their concern with other related adjacent words, one can understand. But for a native person or for a foreign person, this is create confusion. So in this case it creates the ambiguity. So NLP applications are needed a better understanding for giving the better performance, and so that this POS tagging is very important in the case of designing any application. And for we need a good grammatical tool used as a basic tool for the design system. These are the rule based POS tagging and its function. So rule based systems use mainly the grammatical rules and other expertise, language expertise. Obviously these rule based systems have the collection of their handwritten own grammatical rules, as well as these rules are implemented in form of the Marathi dictionary, and these rules and these particular word set or dictionaries are generally used for performing this tagging or analysis of these tags for the particular word. So these are divided into 2 parts. First of all, from the dictionary we can assign a particular word, a particular part of speech tags. They may be multiple in some cases, and another next step we remove the ambiguity and assign a single tag for the particular one word. Now here we have different types of respective subtypes depending on rules for the generating them, how rules are generated for the tag. So we have different here. For example, I take two example, one the noun phrase, another the pronoun. So depending on this, we their definitions, like noun phrase is a group of some words headed by some nouns, or some include some modifier. If we consider example of common noun, so it is nothing but a specific name given to us a particular say, the place or particular person, like this from their definitions. And for their grammatical definition, we can design some rules for each the type of the word they are designed for the Marathi. Like here I give example, the common noun, if the word denotes a class entity or a word has a uni-identical class, then it is considered as the common noun or a common noun phrase. So for example, तो एक मुलगा आहे, this in this word in this sentence मुलगा is the common noun. Another example, ही सर्वात मोठी नदी आहे, it is the largest river. River is or nadi is the common noun here. We cannot get a specific name for this. Same way we have these rules, design rules for proper noun, the abstract noun, verbal noun, and each the type of all the words. Like here from this specification, we give some particular examples, like how these common rules are identified, or what is their, how they satisfied their definitions. Now here we do some literature survey. From literature survey, we can conclude some ideas how many systems are available, for which languages they are available. For Hindi, Bangla and other particular languages, these systems are available. But for Marathi, very less systems are available. And so we considering this point, we decide to develop and develop such a particular post tagging system for Marathi, or tagger for the Marathi, which gives more accuracy. As a database system, we take 25 different moral stories. They are online available. Obviously, they are in Marathi, and they consist Marathi text. The total story words are 5,012 words are there. From these stories we collect, and we use it as a database. And for means whole the system is trained for or using this 5,1200 words. So here we have the proposed system architecture. This diagram shows and gives you idea about the post tagger system for the Marathi. So it is divided into 5 different stages. We have the Marathi input story as an input source document. Then we perform pre-processing on this. This pre-processing consists two different operations: sentence tokenization, word tokenization. These tokenizations are nothing but a splitting of para into sentence. This is the sentence tokenization. Whereas the sentences are again split up into individual words, known as the word tokenization. And then after that, using the tag data set or the database predefined tag data set, we apply assign some particular tag for each the word. But for comparison, we use here the Marathi shallow parser that is designed by IIT Hyderabad, Marathi shallow parser. Using this, we generate a particular tag for each the word, and somewhere we find there are some incorrect tags. They are specified by the shallow parser. So using our manual tag data set, we assign a correct tag and generate appropriate single tag for the word after removing the ambiguity. For example, I give you one example, that is for sentence tokenization. We have this sentence, एक होता उंदीर and तो एकदा फिरायला निघाला. That means in paragraph we have lots of the sentences, but we take these two sentences, they are separated by commas. This is the sentence tokenization, and same sentence is tokenized for word. It is known as word tokenization. Individual words are formed and they are separated by the commas itself. And when we apply the rule-based post tagging, the system will means when we use shallow parser, apply shallow parser, this this is the word. For this it generates some tag hota. For this the shallow parser means for each this word, individual word, a shallow parser generates some particular tag, and we find that this undir, for this undir word, the shallow parser generates JJ, as this is JJ for the adjective, but it is not an adjective. according to us and the grammatical rule of Marathi, it is known as a common word. So we tag, our system tag it as NN, that is a common noun. For next to the for Nigala, the next word is the box. For this shallow person, the for
Vaishali,
yes.
you have over time. You can conclude your presentation.
Okay, okay. Ma'am, this is the result, the final slide. This gives you idea about the result. We apply shallow person and the total words are 512. The shallow person tag 4,658 words and it is unable to tag 354 words correctly. And the accuracy will be calculated as 92.93%. But our system, when we apply our rule set and all the knowledge or dictionary, using this the whole data will be correct, means data are correctly tagged for 4,890 words and 122 words are not correctly tagged by our system, and the accuracy will be calculated at 97.56 as compared to the shallow person. So it is found to be good accuracy as compared to other particular parsers. So for this calculation we use this formula, that is accuracy number of correct tag words and divided by number of correct tag words plus the incorrect tag words and multiplied with the 100. Now at last the conclusion. This post tagging plays an important role in the development of any NLP application. This is used as a basic pre-processing tool for any NLP application. In case of when very less information is available or some grammatical mistakes or some particular syntax related mistakes are there, our system gives you better performance. We can tag properly and we can generate and conclude some idea for meaning of the particular sentence or particular word. Marathi is a free order language, so there are different kinds of post tagger available for other particular languages. But for Marathi, it is very less work has been done. It is fine through the overall study. Little work has been done on the post tagger, and to achieve better accuracy for Marathi national language text processing, we need a powerful tool and more accurate tool. So we this approach is designed for Marathi language, and as compared to the IIT Hyderabad shallow person, our system gives the better accuracy. And in future, when we discuss the drawbacks, what are the drawbacks? Now our data set has a very limited data, and so the accuracy will be good for that particular context. But as we need to use it generalized, so we have to enhance the database. So in future, we have to give concentration on enhancing the database. Last, the acknowledgement. This is the whole work is done and supported by Department of Computer Science and Information Technology. It is DST funded computational psycholinguistic laboratory, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad. And also I am thankful to Sarthi organization for awarding the PhD fellowship. And thank you to ICTIS for giving me chance to present my work in the conference. Thank you, ma'am. These are the references. Thank you. Hello.
Yeah.
Yes, ma'am, I am audible.
Yes. Vaishali ma'am,
Yes, ma'am.
if any word is grammatically wrong, suppose we
Yes.
have taken the example of undir, but there is no rasva e velanti to the
Yes.
if it is undar, so how your system reacts?
Ma'am, system will not generate any response for this because it is a predefined corpora is needed. We have dictionary. If word is unknown to the system, then system is helpless to tag this word.
Okay. And second question is, what is missing in shallow parser because of which you are getting the better accuracy?
Yes, repeat again, ma'am.
what is missing in the shallow parser, which you have implemented and because of which you are getting the better accuracy than the shallow parser?
Yes, ma'am, there are some words. Now, in example, I take words. When we apply, give input to the shallow parser, it tags every word. But in some cases, the words are not tagged properly. They generate a wrong tag for the particular word. According to the whole sentence, when we want to generate the meaning of the sentence, we need to have the expert knowledge about understanding the words and its type, grammatical type for that word and the language. See, this somewhere it is missing, and so to overcome these ideas or this particular is to overcome this particular fault from the tagging process, we try to implement such a system which can obviously it requires a manual data collection for each this word, but we are trying to implement this using the deep study of Marathi, their grammar, and by taking help from some particular knowledge they are available related to the language and the concern they are given by different expertise.
Okay, ma'am. Thank you. Thank you.
Thank you, ma'am.
Yes, ma'am. How do you find the root words? For that, what you are using for finding the root words?
Sir, here for this particular one, there are two different approaches. We can go through the root word also, but as we are designing a manual data set or data dictionary for this, so instead of that, we are trained our system with particular specific words and their particular tags. So here we cannot use stemming, but in future or another concept is there, we can go through the stemming also.
Yes, yeah, there is some sort of analyzer called as morphological analyzer. Have you gone
Yes, sir.
through that?
Yes. No, sir. For my system, I cannot use this directly. I give data set, we create manual data set, and then we apply, compare it with shallow person and try to generate the particular words and the accurate tag for the particular input text.
Okay, fine, ma'am. Okay.
Thank you, sir.
Thank you, madam. Yes. Next we have. Okay.
Everybody see my screen?
Yes.
Yes.
Hello, good afternoon, everyone. Myself, Jaydeep Motisaria. I am from Laurentian University, Canada. So my paper title is Twitter Sentiment Analysis of the 2019 Indian Election. So like research background is like in 2019 Indian Lok Sabha election, so around like 360 million tweet on the Twitter, giving their opinion and showing the sentiment toward the political leader and their parties. So like we have performed text mining on approximately 2 lakh tweet collected over 4 months, like election period, that reference for national party like BJP, Congress, AAP and BSP. We have used wider model to perform sentiment analysis, especially to calculate polarity expressed in social media rather than the using traditional dictionary-based approach. That means WordNet for positive, negative, neutral polarity keywords. And we have found the result of analysis of Bharatiya Janata Party BJP is the being lead runner with the people showing more positive intent and emotion towards their campaign and their leader Narendra Modi. Research objective with the historical data for the period of 4 months, like first Feb 2019 to 23rd May of 2019, we have tried to relate public opinion and emotion with the party and campaign timeline and find out if there was the pattern hidden. And we also find out the political orientation of the users of the Twitter toward the leading parties, BJP, Congress, AAP, and BSP. Furthermore, this research aim to conduct exploratory data analysis and use the data visualization technique for the analyzing tweet daily, weekly, monthly for the each party and its leader. This sentiment analysis also helps to understand the popularity of the party and its leader during their campaigning period. Here, the overview of the Indian election. India is the largest democracy during the year of 2019. The election was held for the 543 parliament seat all over the India. A party required to win 270 seats for the majority to be elected at the center. In 2019 general election had the largest election in the world. Election Commissioner of the India conducted the election in total 7 phases over the 7 weeks. The first phase start on the 11th of April and the seventh phase commencing on the 19th of the May 2019. And the election result declared on the 23rd May 2019. In the India, total 600 million voters polled their vote in 2019, which was the highest record voter in the world. Here is the Indian map. There is the showing total different 7 phase. First stage start on the I told 11th of April and last stage on the 19th of the May. So here is the methodology of this research. First we have collected data, then we have filter after the keyword, then we data process, and then we perform sentiment analysis. So data collection, we have used Twitter archiver source to extract the historical data for the relevant keyword from 1st February to 23rd of May 2019. This is the period where the most of event took the place for the 2019 Lok Sabha election. The data was downloaded as a compressed tar file for the each day of the month. It's almost 50 GB, and then after we have processed the data and we have separate the data for the each keyword, and we have mapped with the each candidate and its candidate leader. Next step is the data pre-processing. Data pre-processing is the fundamental step in the text mining analysis. It is the required step before the performing NLP. Without pre-processing, it can be difficult to calculate polarity of any text, and we may get an incorrect result. And we have used this algorithm for the data cleaning. So I have removed the URL, replace username, filter hashtag, and we have just remove extra character and replace more special character, and remove stop word, wrong constraint, and replacing keyword. So we have used the wider sentiment analysis model. So wider sentiment lexicon provides the both intensity and polarity expressed on social media text. Wider sentiment lexicon administer polarity, strength, and so on in the social media content. Wider also provide a normalized weighted composition score, also called compound score. So compound score is basically sum of the valence score of each word in the lexicon, and then it's normalized to range in -1 to +1, where the -1 meaning is the most negative and +1 meaning is the most positive. Here the positive sentiment compound score is the greater than is equal to 0, 1, and negative compound score is the less than is equal to -1. If the -1 minus 0.1 and less than of 0.01, then we can just categorize in the neutral sentiment. So here is our result. So we have data extracted from the user tweet from the 1st February 2019 to 23rd May 2019. We have perform sentiment analysis on 2 lakh tweet after the data cleaning. After conducting data pre-processing step by cleaning the raw tweet and mapping each tweet to the party and its candidate. The distribution of user tweets show that during election campaign, BJP and Congress were two major parties for the whom public was showing more interest, and followed by AAP and BSP. So here we can see table 1. There is the parties number of tweet, and table 2 is the number of tweet for candidates. So BJP is a 1,54,667 tweet, Congress is a 33,260 tweet, AAP is 8,497, and BSP is a 185 tweet. Same as the candidate tweet, Narendra Modi is a candidate of BJP, and his tweet is like 1,35,822. Same as Rahul Gandhi, 27,868 tweet. Arvind Kejriwal for the 20,222, and Mayawati is like 161. So here is the party analyze change in sentiment. Like here in the figure, we can see like figure the display average sentiment value for the each month during campaigning period. So here is the showing like 0. Like as I mentioned here, like 0.01 is the like positive and minus 0.1 is the negative. Is the minus 0.1 and minus 0.1 is the like neutral tweet. So here is like you can easily interpret like is the showing all the above 0.1 is the positive side, below the 0.1 is the negative side. It's like 0. Minus 1 to plus 0.1 is the like neutral tweet. So like BSP has a higher sentiment score than other party. The reason is BSP is a lower number of user tweets than other party. Therefore, taking the overalls more than other party. All other party have like seen overall sentiment positive, sharing the positive side during the initial election campaign period. April and May, when the actual voting started in the phase the country wide except the BJP, all other party has seen shift in sentiment on the negative, especially smaller party like AAP and BSP. Same as like candidate side, the similar trend to observe change in sentiment for each candidate and party over the campaigning period. This figure is show the overall sentiment of the user tweet for the candidate Narendra Modi as doubles election has started. The candidate appointed by the Congress is Rahul Gandhi as the significant drop in overall sentiment. And this is the same for Arvind Kejriwal up and for the whom overall sentiment was negative on the May month. Here the comparison of the like party and candidate. So here we can easily interpret it. The BJP has a more positive sentiment and lower the negative sentiment, and neutral is the compared to all other party is the same as a like candidate wise. Narendra Modi is a more positive sentiment analysis compared to all other candidate, and same other like negative sentiment is the less compared to all other candidate. Same as a neutral network. BJP won the election, whooping like 303 seats out of 542 seats. Congress won second highest number of seats in the Lok Sabha election 2019, where due to higher popularity of Narendra Modi among the people, and since he was existing prime minister during 2019 election. Rahul Gandhi, candidate of Congress, failed to reserve the majority, and in contrast, Congress is able to win merely 52 seats. Conclusion. The main conclusion is the target was to conduct the Twitter sentiment analysis for the 2019 Indian election major party and their candidate. We have used Vaden model to perform sentiment analysis, especially to calculate polarity expressed in social media, rather than using traditional dictionary-based approach that maintain WordNet for positive, negative, and neural network. And it was seen the people had a higher positive sentiment and emotion for Narendra Modi and its party BJP than Congress, AAP, and BSP. The result of sentiment analysis followed the actual election result, which resulted in the BJP winning the election by majority. This is the reference abbreviation. Thank you. Hello.
Hello.
Yes.
If in the input data fake tweets are there, how did you identify that?
Yeah, madam, we have just data retrieved from the one of the source, Twitter archive source. So I have like collected raw tweet, like for example, I have collected historical tweet. So there is the like 50 GBs of tweet and 2 million tweet. Then after I have just filtered a tweet using the election party and leader. For example, there is the four party BJP, Congress, AAP, and BSP, and four candidate Narendra Modi, Arvind Kejriwal, Rahul Gandhi, and like Mamta Banerjee, for example. So I have just mapped and filtered the tweet using that keyword only. So I am not using like live the tweet. That's why there is no any fake tweet detection.
Okay. Okay. That's
Sir,
an
have you checked the plagiarism of such your research work, whatever you have done?
Yeah. We already checked.
Because as per my knowledge, for this sentimental analysis of Twitter data with respect to general election in India 2019, it is the research is published before.
Yeah, but there is a several kind of research yet done. We have used like sentiment analysis on 4 different party and we have historical data used. Some people are trying to predict on the mood detection and kind of like who is going to popular trending, and we have just processed a vast amount of data. For example, I told you like I have collected 2 million tweet and I have just processing the 2 million tweet, and then after I just filter it.
Okay, that's it.
Yeah.
Yes. Now we have Jane. Do you read? Are you there?
Okay, I'm here.
Yes, you can.
I can present now.
Yeah.
Okay. Okay, I see my screen.
Yes.
Okay. Okay. Hello, everyone. I'm presents my paper is about a processing of top key accurate query on distributed data. My name is Chiu Minh Lee. Okay, the content of this presentation have 5 parts. The top key acceleration query on distributed data, and the second is random access and sequence access techniques. And the third, I will present about the best position algorithm and the no random access algorithm for the top key acceleration query on distributed data. And the fourth is evaluation the 2 algorithm. The last one is a conclusion. Top key acceleration query on distributed data is used in the middleware. The process of top key query is performed on a number of lists being at a various location or separated sources. In each list, data is sorted according to the local score. A score of the accelerating function is calculated by a local score in all lists having the same identifier. The top key answer is a set contain the highest score of the data tuples. For example, in here we have a 3 short list in distributed database. The top key query with a sum function will return a top 3 tuple. That is A366 is here. A366 in 3 lists, list 1 and list 2 and 3. It have the same ID. The sum of the score is 66. And the second is 88. It have the sum is 64. And the last one is A4. It's 63, this overall score. This is the answer set of the top three query with a sum function. Okay. For 2 techniques we can use to answer the top 3 query. Is a sequence access techniques and the random access techniques. The sequence access technique is the data being read or written sequentially by a computer system. The random access is the ability to read or write information anywhere in the database. It is clear that the random access is more time consuming than the sequence access when accessing the data unit. In here, I will present the best position algorithm. This is the algorithm using the both sequence access and random access to find the top 3 best top three tuple with the sum function. In here, in this algorithm, I have to present more detail in my paper. And the most important thing of this one is we find the lambda. The lambda is just at the threshold. The lambda just at the threshold to stop condition. When the sum up the sum, when we find the top 3 best score, we have to stop the condition. In here, we run 10 steps and we find the 62. The 62 is the lambda, is a threshold, and we compare with the minimum of 3 score, A3, A2, A3, A8, and A4. The minimum of 3 value is 63, and we have the stop algorithm. This one is we will not process on up the database. We just stop earlier we want. Okay, stop earlier. And the next one is a no random access algorithm. The no random access algorithm is the just use the sequence access. We don't use the random access. It is in this algorithm we can find the top 3 in the top 1 in step 3, step 5, the top 1 in step 5, because the lower bound is a greater than upper bound, and we can obtain the top 1 in A3. And after that, we run into step 7, and we found that the lower bound is greater than upper bound, and we can obtain the top 2 as well, and we can obtain the top 3. And the answer sets will be A3, A8, and A4. It will meet the previous algorithm, the same with the algorithm. And we evaluation 2 algorithm with the data sets were generated following the normal distribution on the score from 100 to 10,000. The arithmetic function in this query is some function. The algorithm will execute on this generated data set. We obtain the result shown in these figures. Okay, this is the light color, the blue light colors in this one. This is a best position and algorithm, and the red light colors here is a no random access algorithm. And we see that the no random access algorithm is better than the best position algorithm. Due to the server and source or the techniques of management system, the random access and sequence access are supported in the middleware system. In terms of the complexities,
Sorry to interrupt you.
Sorry?
No, last 1 minute for your presentation.
Okay. In terms of the complexity, the no random access algorithm is a little better than the best position algorithm. In terms of the runtime, the no random access method is more effective than the best position algorithm methods on the runtime. The main reason is that the sequential access is faster than the random access on the database management system. In conclusion, in future works, various techniques to extract information, data discovery, and data mining will be closely studied. In expanding of data such as uncertain data, probabilistic data, and fuzzy data, it is crucial to study the top key query on probabilistic distributed data with a random access and sequential access. We will investigate and apply this technique to get a better performance in this query processing and optimize the algorithm on uncertain data. Okay, I finished my presentation. Thank you very much for your attention. Thank you very much for your attention.
Yes, Gita madam, Nilesh sir, have you any questions?
Yes. Basically, whenever we are dealing with this K queries or top K queries, we are focusing on decision making, right?
Decision making, yes.
Yes. So for decision making, what parameters you have considered for this decision making?
The parameter for this consider is a top key. For the first one is for example, we just found that what is the highest score? What is the highest score?
On what basis you have calculated the score?
It is the sum function.
Okay.
The sum function here.
Okay, some function. For data, now for this data, have you used the relational database or distributed system? What you have used for this?
The database for this one.
Yes.
This is the generating data. I just generate the data. Random data.
Okay, random data you have used.
Yes.
Okay. Yes, Geeta madam, any questions from your side?
No question.
Okay, fine.
Okay, thank you very much.
Okay. Now we have one presenter from previous session, one last presenter. Swati.
Yes.
She have a meat issue in earlier session, so now you can start your presentation.
Okay.
You have 8 minutes for your presentation.
Okay.
Now you can share your screen.
I'm sharing my screen. Let me know once you can see my screen.
Yes, it is visible. Please start.
Okay. So good evening all. I'm Ashwati Balachandran, currently pursuing post-graduation in cybersecurity. The topic for my presentation is on VPN network traffic classification using entropy estimation and time-related features. My paper ID is 498. We know that encrypted traffic classification plays a vital role in the cybersecurity field as network traffic encryption becomes prevalent. Thus, internet traffic classification has become more important with rapid growth of current internet network and online applications. So it is one of the important tasks in modern communication networks. So mainly due to the rapid growth of high throughput traffic demands. In order to properly manage the network resources, it is very important to recognize the different types of applications utilizing the network resources. Thus, this accurate traffic classification has become one of the prerequisites for the advanced network management task as the quality of service, anomaly detection, and so on. The emergence of the new applications as well as the interactions between the different components of the internet has actually increased the complexity and the diversity of the network, which actually makes it so challenging for the traffic classification. So as part of the literature survey, there are many studies that have focused on the network traffic classification technologies. One of the oldest and well-known method used for this approach is port-based classification. It is the simplest and fastest method for network traffic categorization. Even though it performs well, it is not practical as port usage is unregulated, and so it cannot reliably classify the network traffic. So then the data packet inspection and classical machine learning methods were used, but their accuracy have been declined due to the increase in the encrypted traffic. And one method was of deep packet inspection system, which can only inspect the encrypted payload without the decryption, but it can only process the HTTP traffic. And then comes a deep learning based approach, which gives more accurate results. And also in the past, most of the old approaches uses predefined features extracted by the expert in order to classify the network traffic. But here it integrates both the feature extraction and the classification pieces into the one system. And then comes the flow-based classification method to time-related features. My project is that additional feature and also to find the accuracy of the results as well as the importance of the selected features in the data set. So now let's go to the methodology of the project that we used. So what we used here is we proposed a model that comprises the entropy estimation and machine learning methods like ANN, random forest, and KNN for both traffic characterization and application identification tasks. So the network traffic data were first preprocessed before being input into the model. We trained and tested like on 80% training and 20% test data. So in the proposed model, we compute entropy for the encrypted network traffic classification after selecting the necessary features for our model. After pre-processing, we'll compute the entropy as an additional feature. So that is first, the network traffic is classified as encrypted or plain text. Then with the entropy estimation, then further it is classified based on the ML approach. So why entropy is because which increases the entropy value. So here we are considering the VPN traffic as well. That means the entropy value will be high. So at first we'll categorize based on that. Then those input will give it as a feature to the ML model. So for encrypted traffic, like due to the randomness, the value will be high as I mentioned. So that is how the approach works. So for my project, VPN on VPN dataset. I have selected the time-related features which speed up the efficiency of the model too. So time taken for the prediction of the model will be less. So in this dataset, they have captured the regular session and one session over the VPN. And so altogether have a total of 14 traffic categories as like VoIP, VPN, VoIP, and P2P and so on. So inside browsing, performing any task which includes the use of a browser for file transfer, like we are talking about the file transfer when live, they have captured the Skype file transfer, that is FTP over SSH, that is Facebook, Hangout, protocols like BitTorrent. So in order to generate this traffic, they have downloaded the torrent file, have captured the traffic sessions. And then in order to capture the VPN traffic, they have used an external VPN service provider and connected to it using the Open VPN. So like we have 28 gigabytes of data. It was captured using Wireshark and TCP dump, and also in order to facilitate the labeling process while capturing the traffic, all the unnecessary services and applications were closed. So this is all about the selected data set. So these are the algorithms that we used for the comparison for the approach. So it's basically the comparison of the existing data set for all the three algorithms. So then when it comes to the performance metrics, we have considered it comes to the precision, it emphasizes on whether like it's a good when a good result of positive predictions is required, and recall is effective when we expect our model to select as many positive samples from the actual positives, and F1 score is a balance between the recall and the precision. So then comes to the results of our approach. So like these were directly classified without computing the entropy and after computing the entropy. So for traffic categorization, random forest shows better performance than others. And for application identification, random forest gives an accuracy rate of 0.88. And then this presents a performance of after computing the entropy as an additional feature in the data set for our proposed three models. So we could find a good difference in their performance comparing to the previous approach for all the three models. Hence, for selected VPN and non-VPN data set, computing entropy as an additional feature shows better accuracy and efficiency in both traffic classification and application identification tasks. The weighted average F1 score of about 0.90 respectively, implying that our models are capable of accurately classifying the VPN and non-VPN traffic categorization and application identification. Then comes to the conclusion. the results using various algorithms like ANN, and random forest for network traffic characterization, application identification, and segregation of VPN and non-VPN traffic. Our work actually emphasizes the importance of entropy for classifying the VPN traffic. As it is encrypted, it shows higher value. So with the help of that, we could actually classify it more accurately and efficiently. So our results prove the proposed model with entropy as an additional feature, achieving accuracy levels above 90% for all the three algorithms. Overall, random forest showed the best results in both normal and combined approach of more than 90%, and KNN and ANN gained more momentum and showed a significant increase in the accuracy from 0.81 to 0.94 and 0.81 to 0.98 when the entropy parameter is considered. So as a future work, a detailed analysis of encryption protocols such as TLS 1.3 and also can be performed along with this, and the proposed model can be improved to be more efficient to perform more complicated tasks like multi-channel and accurately classifying TORs, traffic, etc. And also this is only limited to this particular data set and for this particular algorithms. So we haven't tried this on any other data set or in real time. So that is also a limitation, or as a future work we can say. So these are the references that I've used. Thank you.
Yes. Madam, you have any question?
Yeah, no questions, because she has mentioned that in the future work, which I was supposed to ask.
Yes, sir.
Out of there are the 3 traffic encryption mechanisms. Out of that, which encryption mechanisms you have used?
Here from the existing data set, we have actually used VPN and non-VPN, right? So these SSL and TLS, SSL protocol and TLS protocol, all I have mentioned it in the data set, right? So FTP and HTTPS, all the mechanism, or like whatever it was existing in the present data set, we have taken into consideration. So.
Fine. Okay, that's it, madam.
Thank you.
Now we all done with the presentation. I sincerely thank our authors for their excellent presentations in this session, and all our participants for being a part of this international conference. Listeners should be getting their digital certificate email within 2 working days. Further, all papers have already been forwarded to the within 36 times. Now, I would like to thank our session chair, Mr. Nawale. Thank you for chairing this session. Here is one of your appreciation for the conference. Thank you for your valuable time. Thanks, Mr. Now at last, can you open your camera for quick snapshot, please? All of you?
Thank you, Dr. Nilesh, and thank you, Dr. Geeta,
Thank you, Amit
for
sir. Thank you.
sparing your valuable time once again.
Yes.
And
Thank
we
you, Amit
appreciate
sir.
your efforts always, and look forward to see you many times in near future.
Sure, sir. Sure. Definitely.
I think, Disha, what certificate you have shown was not displayed properly. So can you just show it once again?
It's okay, sir. No issues.
Yeah, this is for Nilesh sir, and for Dr. Geeta as well.
I already shared.
Thank you, Disha.
Yeah, thank you. Thank you, Disha ma'am. Thank you, Amit sir.
Full screen so I can.
Thank you.
The concern, what we can say, continuous follow-up from Disha ma'am.
Thank you very much, and thank you, Disha, for this valuable contribution to ICTIS 2021, and Dr. Nilesh and Dr. Geeta as the chairs, and all the participants who have contributed to the ICTIS 2021. I understand that it is a quite hectic process, a process of 5 to 6 months, but support your patience and your commitment towards the organization and the conference. Thank you. Disha, over to you.
And actually, really, papers were very nice, and presentation was timely completed by all the participants. And one thing I would like to address is that they have concentrated on the research work, and you can say perfect research methodology they have applied, and they have presented their work. A good work by all the participants.
So this credit is to all the authors.
Yes, yes, yes.
Thank you, thank you.
Yeah.
And Disha, anything for closing remarks left down? It's all done. So thank you very much. I think authors have already been intimated that they will also receive the certificates within a couple of days once the conference is over. So thank you for your patience, and we look forward to you for day 2. Tomorrow also there will be around 12 parallel sessions in the whole day. So we look forward to your participation. Thank you. Thank you.
Thank you. Thank you.